Diesel fuel systems use a plunger and barrel to pump high-pressure fuel into the combustion chamber. The cam lobes, push rods, and rocker arms mechanically actuate the injectors. The term EUI is actually an abbreviation for mechanically actuated, electronically controlled unit injector. Major parts of the injector include the tappet, plunger, barrel and body, nozzle assembly, and cartridge valve. The nozzle assembly consists of a nozzle spring, nozzle check, and nozzle tip. The cartridge valve consists of a solenoid, armature, poppet valve, and poppet spring. The injector is mounted in an injector bore in the cylinder head, which has an integral fuel supply passage. On older engines, the injector seated on a brass sleeve, which was swaged into the bottom of the injector bore. The brass sleeve provided a combustion seal and separated the injector from engine coolant in the water jacket. On 3406E engines, an improved stainless steel sleeve is used. This sleeve also separates the injector from engine coolant, but the injector actually does not touch the sleeve. Supply fuel is sealed above the sleeve by an external injector O-ring, and the cavity between the injector and sleeve is empty. The injector nozzle case seats directly on the cylinder head to provide a more positive combustion gas seal. The sleeve is installed with a light press fit and O-rings rather than the mechanical swaging used on brass sleeves. Increased wall thickness on the stainless steel sleeve allows the use of internal threads. These threads make sleeve installation and removal much easier. C10, C12 engines also use a stainless steel sleeve similar to the 3406E. Rather than using O-rings, this sleeve fits in the cylinder head with a light press fit and is sealed using retaining compound on the upper and lower lands. Actuation refers to the type of force used to power the plunger, which pumps the fuel out of the injector. Mechanically actuated fuel systems use a camshaft lobe and rocker arm to provide that force. The rocker arm presses down on the tappet at the top of the injector. The tappet, in turn, presses down on the injector plunger, which pushes fuel from the plunger cavity below the plunger. Fuel displaced from the plunger cavity can flow in two directions. Fuel can flow to the nozzle assembly and to the nozzle tip. However, to flow out of the tip, the injection pressure must reach about 5,000 psi in order to raise the nozzle check against the force of the nozzle spring. The fuel chooses the path of least resistance. It flows around the normally open poppet in the cartridge valve assembly to the fuel supply passage in the cylinder head. When injection is desired, the ECM sends a current to the solenoid on the cartridge valve. The current creates a magnetic field, causing the poppet to close. Fuel flow past the poppet is blocked, and pressure begins to build from the poppet through the plunger cavity to the nozzle check. When the pressure reaches approximately 5,000 psi, the force of the high-pressure fuel overcomes the spring tension holding the nozzle check closed. The check lifts off its seat and fuel flows out of the orifice holes in the nozzle tip. This is the start of injection. The rapid flow of fuel out of the plunger cavity is restricted by the very small orifice holes. Because of this restriction, injection pressure continues to rise very rapidly, even after the nozzle check opens and injection begins. Injection pressures continue to rise until the flow rate out of the orifice holes equals that of the fuel leaving the plunger cavity. Depending on engine speed and fuel delivery, this pressure ranges from 10,000 to 30,000 psi. High injection pressures promote complete combustion and lower exhaust emissions. Pushing the fuel through the orifice holes in the nozzle tip causes the fuel to atomize into droplets in the combustion chamber. Fuel droplets burn from the outside into the center, Large droplets take longer to burn and may not have time to burn completely during a normal combustion cycle. Increasing the pressure of the fuel through the orifice holes creates smaller droplets. In turn, smaller droplets burn more completely. There are 4 stages in the operation of the EUI: pre-injection, injection, spill, and fill. The first stage, pre-injection, starts with the plunger and tappet at the top of their stroke. The plunger cavity is full of fuel, the poppet in the cartridge is open, and the nozzle check is closed. Fuel leaves the plunger cavity when the rocker arm pushes down on the tappet and plunger. Fuel blocked by the closed nozzle check flows past the open poppet to the fuel supply passage in the cylinder head. As long as the solenoid on the cartridge valve is not energized, the poppet remains open, and fuel from the plunger cavity continues flowing into the fuel supply passage. To start injection, the ECM sends a current to the solenoid on the cartridge valve. The solenoid creates a magnetic field which attracts the armature. When the solenoid is energized, the armature lifts the poppet until it contacts the poppet seat. Once the poppet closes, the flow path for the fuel leaving the plunger cavity is blocked. As fuel continues out of the plunger cavity, pressure builds very rapidly. The poppet transfers this pressure through the plunger cavity to the nozzle assembly. When fuel pressure reaches approximately 5,000 psi, the nozzle check lifts off its seat and fuel flows out the tip. This is the start of injection. Injection pressure continues to build very rapidly until the same volume of fuel, pumping out of the plunger cavity, sprays from the tip. Injection occurs as long as the plunger continues to move down and the energized solenoid holds the poppet closed. When it decides that injection should end, the ECM stops current flow to the solenoid. This collapses the magnetic field holding the poppet closed. Spring and flow forces open the poppet almost instantly. High-pressure fuel can now flow around the open poppet and into the fuel supply passage. With fuel injection pressures approaching 30,000 psi, the velocity of the fuel flowing around the poppet into the 100 psi fuel supply passage is very high. This results in a rapid drop in injection pressure. When injection pressure falls to about 3,500 psi, the nozzle check closes and injection stops. This is end of injection. The extremely fast pressure drop from peak injection to end of injection reduces particulate emissions and is an important benefit of EUI. Let's review the operation of the cartridge valve, which is the heart of the EUI injector. In order to perform correctly, this valve must be able to open and close almost instantly, seal injection pressures of 30,000 psi, and prevent leakage of high-pressure fuel during injection. Containing these elevated injection pressures without leakage requires extraordinary manufacturing precision and tolerances. Any high-pressure fuel leaking past the poppet during injection is not delivered into the combustion chamber.